purpose of this video is for you to be able to describe the basic properties of acids and bases. Now, some terms that we're going to use. An ion is an atom or atoms with a charge, positive or negative. And a solution is when you've got heterogeneous mixture with two or more substances in a single phase. The phase is typically liquid, and it's most common. It's going to be something dissolved in something else, like salt dissolved in water. Now, an acid is a compound that when you put it in water or put it in a liquid, it increases hydronium ions concentration. So here I've got some water, and I plop the acid in, and if these little dots represent hydronium, then after I put them in, you see there are dots there that are the hydronium ions. Now, you really, if this were real, you wouldn't see anything. The solution would really be the same. You couldn't tell it, but by looking at it. However, the hydroniums are there in the solution after you've added the acid. And a hydronium ion looks like this. You've got one oxygen and three hydrogens surrounding it, and it has a positive charge, so it's H3O+. Now, a base is very similar to an acid, except instead of increasing hydronium, the base introduces hydroxide ions, or increases the hydroxide ions in there. So I add the base to the water, and now I've got hydroxide ions floating around in there. Once again, you wouldn't see them, but they would be there. Now, a hydroxide is OH negative, so one oxygen, one hydrogen together with a negative charge. Now, some acidic properties. Acids tend to form clear solutions. If I add an acid to water, it's going to be clear. Now, I know I've shown this as gray because I like the color. It would just be clear, like clear water. It starts as clear and it's going to end as clear. You wouldn't be able to tell anybody had added it just by looking at it, because it would be the same before and after. Now, they have a sour taste, acids do. Let's pretend I had some lemon juice. It's a common acid you'd find in like your kitchen. If you were to taste it, it'd be very sour. But you would never ever do this in a laboratory setting to identify an acid. Acids tend to change the color of an acid-base indicator. The most common one that people have used is pH paper. If I take blue pH paper and I put it in an acid, it's going to change that blue pH paper to red, indicating its acidic state. Acids have a tendency, when you put metal in them, to release hydrogen gas. Now, this depends upon the metal and acid. Let's say I had two beakers with the same acid and beat both of them, and I put zinc in one and I put gold in the other. Now, since one of these metals is reactive and one of them is not, I'd have hydrogen bubbles form around the zinc, and gold, nothing would happen. Another property is that they're going to react with a base to form salt and water. Now, let's say I've got my acid and a base. Now, reminder, these would be clear, and you wouldn't have any red and green dots floating around. It would just be clear. But I like the color just to represent the molecules, and then I mix them. Now, I have them both present here. This would really happen the moment that you mix them, they'd start to react. But they're going to couple up, and then you're going to be left with just the salt and water. And the water would be the gray color of the actual solution. And I'd have salt floating around. The salt would be dissolved in the solution itself. So you wouldn't really see it. It would just be clear. Now, the last thing about acids is that they're conductive. Let's say I took a battery and I had two wires coming out of it, and I put two wires in like a loop form and through an acid. This would tend to make a light bulb light, better than just plain solution. That's because the acid makes the solution conductive. Now, basic properties. They also tend to form clear solutions. They're just like an acid. You wouldn't be able to tell them apart by looking at them. They're going to tend to be a clear solution. Bases, on the other hand, have a bitter taste. Back in the day, Dr. Square, when he was a youngster, he really had some bad language. And so what did his parents do? They made him wash his mouth out with soap. That left him with a really bitter taste in his mouth. That's because a lot of soaps have lye in them, or sodium hydroxide, and that's a strong base, and that's what makes his mouth, it makes the taste bitter. Bases, they also do the same thing as acids in that they'll change the color of a pH paper. The most common one that's used is red, but this turns red and it turns it blue. Bases also tend to feel slippery on your skin, dilute solutions of them. Like with soap, when you wash your face, your skin still can sometimes feel slippery after you've done it. That's because you've got some residue base still there, and that means you need to rinse more. Now, the last two are very similar to acids. It's just like the flip side from a base. Bases also react with acids to form a salt and water. And bases are also conductive, just like an acid. They tend to make solutions allow electricity to pass through them.